and great to be here. I'll keep checking, the chat. So if anyone has any questions, please post them there, and I'll get to those during the presentation if I can, but definitely after, and I'll be on Slack for a bit as well. But yes, Eduardo, thanks for the introduction. I'm Mady Mantha. I'm a Senior Technical Evangelist at Rasa, and today I want to talk to you about GPT-3. If you've been following NLP Twitter, anything machine learning and NLP lately, you've probably heard about GPT-3. So we'll talk about what it is, how it's used, its advances, some of its drawbacks and limitations, and really what this means for conversational AI. I work primarily in the conversational AI space. I build conversational AI software and frameworks, so I can sort of touch upon what GPT-3 means for this field and next steps, and then we'll open it up for questions. So a little bit about Rasa before we begin. Our mission at Rasa is to empower everyone to build and use conversational AI. Rasa builds the standard infrastructure layer for conversational AI. So as a data scientist or as a developer, you'd use Rasa to build robust contextual assistants that go beyond answering basic FAQs and can really engage in multi-turn interactions. And the way we do that is through building open source models and infrastructure and championing other open source tools. We have a great community that's nearly 10,000 members strong, and we support them. We also have a research team that I work with that ships applied research directly into the product so that it works reliably when you use it. And then we'll, get into some of that today. We're really blown away by the community that we have, and that we know how essential it is, especially when you're building open source products and tools, to have developers from all across the world build assistants with Rasa. So, what is GPT-3, right? There's certainly lots of hype around it for sure. Folks have used it to write SQL queries. They've used the GPT-3 API, given it some SQL queries as input, presumably, and it generated some SQL queries in return. They've used it to write legal language, probably for contracts and things of that nature. But we'll talk about why this isn't exactly recommended. Folks have also used it to write spreadsheet functions and formulas, which is really impressive because, writing Excel functions can be quite cumbersome and annoying for sure. And again, here they've given it some training data that includes some spreadsheet formulas and equations, and it did some pattern matching of sorts to generate some more functions. And similar to SQL and spreadsheet stuff, folks have claimed that GPT-3 auto-completed code and generated some code rather looking at examples of code. And we'll address issues with serving raw generated text, or the issue with generative models when it comes to directly serving it to users. But this is still really impressive stuff. But of course, not everyone is equally impressed. At the end of the day, some claim it's just a language model, right, that generates text given some input text. There are some really impressive parts, some issues and some drawbacks, and some next steps in terms of what this means for NLP applications in the real world. So let's dig into it now. So what is GPT-3? Simply put, it's a very large language model. It has 175 billion parameters. So it looks at some input text, and given that input text and training data, it probabilistically predicts the next set of tokens. So if you give it a pattern like some SQL queries and start to type a query, it will complete that and complete what comes next in that query. And if you give it a prompt like, Mady will talk about GPT-3, it will probably finish that sentence with something like, Mady will talk about GPT-3 and its architecture or something like that. And similar to GPT-2, it has a transformer-based architecture. It has a stack of 96 transformer decoder layers. And the difference between GPT-3 and 2 is that GPT-3 has alternating dense and sparse self-attention layers. And because of its massive size, which is 175 billion trainable parameters, and its architecture, it claims to perform specific tasks, tasks that require reasoning on the fly without any task-specific fine-tuning. So this is huge because other language models, also large-scale language models like BERT, do require task-specific fine-tuning and task-specific data, etc. But GPT-3 claims to not require that stuff, which means that it can potentially be used out of the box to perform a wide variety of specific NLP tasks without substantial task-specific modifications. And here's how GPT-3 compares when it comes to other language models and also its own predecessors, GPT-1 and GPT-2. If you look at the graph here, the green line is GPT-3, and the other language models, which are also pretty large, are very tiny in comparison, in that you can't even really see them on this graph anymore. They basically disappear and you just see GPT-3. And large-scale models with lots of parameters like GPT-3 need a lot of data to train on. And GPT-3 has been trained on a very large data set. It was trained on Common Crawl, which is an open repository of over 2 petabytes of data from websites, of web crawl data that has been collected for 8 years and ongoing. It was also trained on Web Text 2, which is, something that the authors worked on and came up with, and it's a collection of outbound links from Reddit that have at least 3+ upvotes. And it looks at the text of those web pages that the outbound links have referenced. It was also trained on Books 1 and Books 2 with 12 billion and 55 billion tokens respectively. But they haven't said which books exactly. So it's, we're not entirely sure what these books are just yet. Maybe someone in the chat, if any of you folks are familiar, let me know. But I don't think we're exactly sure what these books are. And finally, it was trained on 3 billion tokens from English Wikipedia web pages. And so it's important to note that about 93% of training data for GPT-3 has been in English. So there's a strong English language bias here. And so if you're building NLP applications that are multilingual or primarily in other languages, then it's probably not going to be as effective. So first, let's talk about how GPT-3 is really impressive, and it is. Now, first of all, it's pretty easy to use. There's an API that you can leverage, and you can use that in your NLP applications. You can integrate the REST API in your app stack. And that is very easy compared to building your own language model or building an API of your own if you want to use another language model. And one of the great things about that is that you don't have to be a machine learning researcher or a data scientist or know a whole lot about NLP to start using something like this right away. There's an easy interface that you can use to give it some input text and use it for tasks such as autocomplete, question answering, translations, search, summarization, sentiment analysis, any type of content generation, so text generation, generating news articles and things like that. And as you saw earlier, we saw some examples of people saying how it generated code for them. In addition, the authors claim that it can do lots of addition, subtraction, and other arithmetic tasks. So all of this means that, it's very democratizing, right? And it's what we want in technology, to include everyone to contribute meaningfully. So ease of use and being able to use for a wide variety of NLP tasks is something super impressive and exciting for sure. And the generated text is logically sound, it's grammatically accurate, and generally accurate for the most part, with just a few training examples or prompts. So that, again, is something that we haven't really seen before, especially on this magnitude, so that's exciting to see. Our research team got access to the API, and we played around with it, and now I want to show you some examples of how it's great, and also how it can be a little problematic. So in this first example here, we gave it a prompt or two as input, where you kind of specify what the task is, and it will figure out what the task is and generate the appropriate text for it. And the bold text that you see on my screen is the input that we gave it. So we typed in question, 1 + 1, answer, 2. And then we typed in question, 1 + 52, and answer. And then it completed that with 53, which is accurate. And then it went on to generate some more examples, right? Which is question, and then answer. So it identified that pattern. And then it matched it with some arithmetic addition, to be specific. And it said 1 + 52 + 1, 54, and that's accurate, right? So it classified the task as addition, and then it identified the question answer format, and then generated an example or two of its own. Then it degraded a bit, where it just said work, and you have the option to correct the text and ask the system to learn that correction and go from there. You could also do some hyperparameter tuning to avoid stuff like this in production or something like that. But our research team pointed out that this behavior occurs frequently. And there's another, similar example here where it's question answering and pattern matching. It identifies the pattern, identifies the task that we'd like for the model to complete, and it generates text. But same as before, the longer the text, the more the model tends to degrade a bit. It got kind of weird at the end there when we said question, when it generated question turtle plus white and the answer being snow, that's not exactly accurate. Or, bird plus black, answer being swan. I guess you could argue that there is a black swan, right? It may have read from some book or something like that. But yeah, a couple of strange examples happening as the text keeps getting longer. And then we did some text generation. We primed the model by giving it a prompt and giving it some examples of a task, and it auto-completed. The responses, as you can see here, are grammatically correct, right? And they're structurally kind of sound in that it definitely is a sentence that it generated. So it looks convincing, but it's stereotypical and maybe bordering on problematic stereotypes about certain cultural and national groups. So we definitely want to be very mindful of things like that happening. And there's definitely no factual accuracy or anything like that being guaranteed. So you want to be mindful of that as well. Couple of examples, that look kind of okay, I guess. Tulips and beer, but it's also like reducing something. All right, and here we give it a prompt, and then longer outputs definitely tend to degrade here, and it's a much longer sentence, and you'll see some issues right away. Again, the sentence here is grammatically correct, logically kind of follows the sentence and story structure, but it's definitely weird and it sticks to national stereotypes. And so for research purposes, it's interesting to see, but it's also very concerning when you think of this being applied potentially in fields like news generation or other types of content generation, where you're serving it directly to users, So, and you'll also notice that not all responses are full sentences, and that's because the amount of text that's generated is a hyperparameter that you'll need to set manually. All right, so now we've seen, some really impressive parts of GPT-3. So let's take a look at some causes for concern and talk about drawbacks and next steps. There is a content warning here, so I'll definitely warn you that there is going to be some racist, sexist, and problematic output coming up. So just be mindful of that. And, if you're definitely sensitive, feel free to skip the next couple of minutes if you like. So here we gave it some prompts based on the paper by Sheng et al. The woman worked for a babysitter on biases in language generation. So check out that paper. It's pretty informative. And there's huge bias, as you can see here, on gender, skin color, sexuality, sexual identification, and others. And this is highly problematic, right? Because GPT-3 was trained, like we talked about, on Common Crawl, Reddit data, which contains abusive language, and there's bias in the text there. And the model that's trained on this text is therefore bound to exhibit bias and even potentially amplify it. So there's definitely a problem of bias, one that the authors admit to, but I'm not entirely sure if there was any debiasing done. And even then, the known debiasing methods aren't proven to be 100% effective in removing bias. There's a paper and study by Gonin and Goldberg 2019, Lipstick on a Pig. Also, check that paper out. I'll post it in the chat in a little bit. That study shows that the current debiasing methods on just gender didn't remove them, but only removed a way to measure bias, because bias is more pervasive and systematic than that. So this is definitely a known issue for generative models. And because of this issue, it's not recommended to serve generated text directly to users without human intervention. So we definitely want to be mindful of things like that. Some of the other drawbacks are that, first of all, it's pretty expensive. The compute cost was about $12 million. So if you wanted to train a version for your own solution for yourself, then it becomes prohibitively expensive. Also, 93% of the training data, as we mentioned, is in English. So it's predominantly an English language model. So if you're building a search or a conversational AI solution in Thai or Hindi or something like that, then it won't be as effective. GPT-3 is also closed, so you have to be invited to use it. And the generated text definitely degrades after a while. The longer the sentences become, so that's something to look at, especially if you want to use it in commercial applications. And another thing you want to look at if you want to use it in commercial applications is the issue, like we talked about, that of abusive output. So if you wanted to use GPT-3 to generate text for your chatbot or AI assistant, then you need to be very careful and use human intervention to validate and check the responses and ensure that you're not sending the generated text unchecked. It will have factual errors, it will degrade, and it has abusive output. So if you're building an AI assistant for a bank or an e-commerce store, then you definitely want a human representative checking the output before you serve it. So, I work in conversational AI. I build conversational software. I also build chatbots. So GPT-3 is certainly a highly impressive and super exciting announcement. And it does a couple of things that are great. It gives developers and technical teams the ability to build robust NLP solutions and doesn't exclude them from the conversations, right? It is able to generate coherent text with just a few training examples. And it can be used for a wide variety of NLP tasks, from question answering to search to content generation. So that's definitely a milestone in terms of what it can generate and the quality with which it can do so. But, what does this mean for conversational AI? Not too much, actually. And the reason for that is that you can't fully automate the process of creating AI assistants. There's a lot that goes into building and serving AI assistants that can't be automated or solved with something like GPT-3. Because the way you build great conversational software is, right, you definitely need great research, great models for both natural language understanding and dialogue management. And just like with any other software application, conversational AI is not that much different. It's not enough to have the most accurate or performant model. Machine learning is no longer a niche field, but a foundational piece of software engineering. So we need to treat it as such. You need solid engineering principles like CI/CD, integrated version control, a microservices architecture, like using something like Kubernetes and Docker and so forth. And one of the cool things about conversational AI is that users will literally tell you what they want, which you don't find in other NLP applications like information retrieval or text analytics, right? They'll ask the contextual assistant something in a way that you haven't trained, or they'll tell you your answer is irrelevant or wrong. So listening to users, collecting that data to add to your training data and automating that process is conversation-driven development. And this is the practice that you might want to follow if you want to build these resilient assistants that work in production. And we're still kind of in the early stages of conversational AI, right? Even though this is something that's been around since the 1960s, but we're still in the early stages of building something that everyone can use. So in order to accomplish this, we actually need a massive open source developer movement where we can bring everyone into this community so that they can contribute meaningfully. So great research and engineering principles is still not exactly enough. You still want to follow the process of listening to your users. And so there are 6 steps involved in conversation-driven development. And these aren't linear actions that you want to take, and you'll find that you go back to reviewing conversations after you've annotated data, and you test things several stages of building your application. So the first thing you want to do is share, give your prototype to as many users as possible and test as early as possible. People will always surprise you with what they can say. Teams will spend months designing conversations that will never happen or over-engineer solutions, so share it with as many users as possible. And definitely take time to review the conversations that people have with your assistant. And this is something that's helpful at every stage of building something. So like from going from prototype to production. And annotate your data. And parts of this, as you can start to tell, can be automated. But just using something like GPT-3 or any kind of large language model isn't an end-all be-all solution. You still need to annotate your training data and improve your NLU model based on conversations from your real users. So when you're building a POC, you can come up with examples yourself, or you can generate hypothetical conversations and synthetic examples that'll help you get started. But make sure that less than 10% of your data is synthetic. And definitely use whole conversations as end-to-end tests for your assistant. Professional teams don't ship applications without tests, right? So definitely write tests and test it with real user conversations as much as possible. And find a way to track and successful conversations and come up with a way to identify successful conversations, like beyond successfully answering a question, but also look at actions and other ways to successfully identify conversations that can be used to take your assistant to the next level. For example, like a user taking an action, like signing up for your service, or not taking an action, like getting back in touch with support after 24 hours. So use that data to tag and filter conversations to understand what's working and what's not working. And definitely, after you continue to do all of this, like study conversations that went smoothly and ones that failed, and fix the ones that failed. You know, successful conversations become tests right away. And you want to use those end-to-end conversations that are happening in your specific domain to continue to improve your NLU model and your overall assistant. So, you know, the next breakthrough in conversational AI or NLP will come through open source technology. It'll come through communities building together and learning together and shipping that applied research directly into the products that we built. Open source definitely makes the field's progress like 10x faster, as it has in many examples, like with the web and so forth. So definitely try to, you know, experiment with things like GPT-3 or other open source NLP technology, you know, try to build something and then go to any kind of forum and share where you got stuck, and then talk to others about how to build robust NLP solutions, as it can definitely be helpful and make the field's progress a lot faster. So we're still kind of in the early stages of building these solutions. And we definitely want to be mindful of models and things like GPT-3, because while they're definitely a great milestone in what we can achieve with them, we definitely want to make sure that we're not automating everything end to end, and we're still checking things and, you know, making sure that we have human intervention, especially when it comes to building well-rounded, holistic, and ethical NLP solutions. So thanks for sticking around. I'm going to check the chat here to see if we got any questions, and it looks like we have, so I'll start to take some questions now. Okay, cool. Can GPT-3 be used for named entity extraction? I mean, so GPT-3 can be used for a wide variety of NLP tasks, and it can be used for like named entity recognition or extraction. So yes, I haven't tried it though, so I can't personally vouch for that. I've tried it for like pattern matching and question answering and text generation and other types of like content generation, but it should be able to. All right, so do you think that after the fact checks for problematic responses will be enough, or does anti-bias need to be built into the models themselves? So that's a great question, Marcus. So if you've read the study by Goldberg and Gonin from 2019, and they did this study on systematic bias in word embeddings, specifically talked about gender bias. So GPT-3 exhibited some abusive output that went beyond just gender bias. We saw like racism and sexism and all of these other things. So one of the experiments that they did was in the particular study that I referenced is they did one debiasing method that was post-processing, and they found that it didn't really remove bias. And one of the other methods that they did was like they did it before the fact. And that was definitely a bit more effective than doing it post-processing, but it still did not remove the issue of bias. And that's because the way that we define bias, whether it's gender bias being defined on the gender direction, it's using cosine similarity. So you take a look at how similar a gender neutral word is to he versus how similar a gender neutral word is to she. That's how you measure, according to the study, gender bias in word embeddings. So they did that, and it still wasn't necessarily, it's a very narrow definition of bias, is what I mean to say. And so when you're defining bias in narrow terms, and you're just removing bias from these word embeddings, it still didn't solve the issue of removing bias itself, but it just like made it harder to measure bias, because bias is pervasive and it's in all of the text that we use to train the models. So maybe we want to create training data ourselves where we don't have this kind of bias. Maybe that's one way to do it. Or we take a look at large scale training data like WordNet and others and try to like manually remove abusive input and such. But I mean, quite know how to remove bias. I think it's an ongoing conversation for sure. But a few methods have not been proven to be super effective, whether that's post-processing or before. So that's a very long answer to your question there. Okay. Alex, do you think it's possible to develop human-like characters for fiction or conversations by tuning GPT-3 parameters, or is the output too random? I think that you might be able to. I think we even saw that in GPT-2. You can still generate, lots of like content in GPT-3. But if you manually set the hyperparameter so that, longer output can still be maintained, I still think that the longer a particular output gets, it starts to degrade and become problematic. The great thing about fiction is that really good fiction has a lot of depth and has a lot of layers, and it's complex. And I don't quite know that GPT-3 is able to generate text that's as layered or complex that, something that humans can come up with. So as you saw in my example here, when we gave it a prompt like the Dutch are known for, it just immediately went to national stereotypes. So, what if it created characters that were just like parodies of themselves? So I'd be interested to see what that looks like, but my guess is probably not. Okay, so are there ethical concerns about the use of GPT-3 or future iterations, aside from the obvious problems of abuse or bias? As in, what ways could this tool be abused by a bad actor? Okay, that's a really good question. So Okay, so in talking about maybe how it can be abused by a bad actor, not talking about like abuse or bias or, racism, sexism and stuff. I think that what if you were to use GPT-3 to build something that was, a conversational AI, an AI assistant or something like that, that asked people for their, personal data and then use that data to do something unethical. I think you could enter into like a lot of legal gray area because, it's not you as a human talking to another human and trying to like fool them or something like that, right? So what if the model itself was programmed to steal someone's data and then use it in a way that's, that it's not meant for? So would that be an ethical concern that maybe a bad actor could use this tool in abuse? Maybe. I'd be interested to see, especially if like the tool is doing something like this and it's not a human that's actually stealing someone's data. Yeah, what would the legal concerns be? So that's definitely interesting. I'd have to think about that a little bit. Okay. I don't think that I fully answered that question, but I'd be interested to like chat with you about what you meant and maybe talk some more. Because if a human isn't stealing someone's data, could they still be prosecuted? I don't know. Okay, so would a practical, so to quantify gender bias, would it make sense to prompt GPT-3 with the woman worked as 100 times and then analyze the distribution of jobs that GPT-3 comes up with? Yeah, I think that might make sense for sure, to see how many times it comes up with stereotypical and sexist professions and occupations as opposed to something that's gender neutral. Or if you wanted to maybe compare, you could say the man worked as, or like the white man worked as, and then it would come up with like doctor and engineer, which are actually gender neutral words, but maybe it would have like a stronger male bias. So you could also use that to compare and contrast in addition to quantifying. And cool, Marcus, thank you for that study link. So I'm gonna check that out.
So cool. Mady, we are running out of time, but thank you very much for your presentation. For everybody, if you want to continue asking questions to Mady, she will be available. I hope you will be available at the expo hall, where she will be there for a while answering your questions live. And then after that, the Slack channel is a good place to ask your questions. So with this, I thank you again very much, Mady, and hope to see you soon.
Yeah, no, thank you. This is fun. Also, I meant to tell you that the power went out in my house, but luckily I'm using my phone data to stream, which is why the light went out. But thanks for sticking around. All right, thank you.
Thank you very much.
All right, bye.